let's go ahead and solve another vector addition problem. This time, we're going to add 5.2 centimeters at 60 degrees and 4.5 centimeters at negative 15 degrees. And if we remember, our length of our arrow is going to represent the magnitude, and the direction of our arrow is going to represent the angle. So let's get started. So we want to go ahead and draw a set of X and Y axes. And this will be my Y-axis, and this will be the X-axis. So we're going to start there. I'll put a little dot at the origin again. That's where I'm going to start things. And it doesn't matter which vector I start with. I guess I'll just start with the one at the top. And the first thing I want to do is measure out the angle, 60 degrees. So I'm going to go ahead and put my protractor right at the origin, the little hole in the protractor right at the origin. Make sure my horizontal line is lined up with the horizontal axis. Make sure my 90-degree mark is lined up with the vertical axis. And then I'm just going to put a small dot at 60 degrees. There it is. Now, I want to go ahead and I want to measure 5.2 centimeters. Now, I'm going to sort of 10x everything here, but on a piece of graph paper, you would go ahead and measure off 5.2 centimeters using your ruler. I am going to measure off 52 centimeters at 60 degrees. So there we go. I'll hold that nice and firm. And all the way up to the 52 mark, right there. And I'm going to put an arrowhead because it is a vector, and we should label this. So I'm going to call this theta sub 1, our first angle, 60 degrees. And I'll just call this x for displacement. Our first displacement is 5.2 centimeters. Now we want to go ahead and sort of repeat this process, but this time we want to do it at the tip of the arrow and not the origin. So let's go ahead and draw another set of X and Y axes. There's my X, and there's my Y-axis. And I want to measure off negative 15 degrees. Now, it's negative, it's a negative angle. So a positive angle goes counterclockwise. This would be 0 degrees. That would be the positive X-axis. So a positive angle would go above the X-axis. A negative angle goes below the positive X-axis. So what I'm going to do is I'm going to take my protractor and I'm simply going to flip it upside down. And I'm going to do the same thing. So there we go. Flip it upside down. I'm going to put the little hole right there at the origin, line up my 90 mark, and make sure that my horizontal line on my protractor lines up with the horizontal axis, and then I want to mark it off at 15, right there, negative 15. So it's below the positive X-axis. And I want to go 4.5 centimeters. So again, I'm going to 10x everything so you can see it. And I'm going to start right at the origin, and I'm going to measure off, 45, right there. And I'm going to put an arrowhead on the end of that. I'm going to measure my angle. So theta sub 2 is negative 15 degrees. We'll call this x sub 2, and that is 4.5 centimeters. And now we are ready to find our resultant. So what I want to do is I'm going to go ahead and use a red marker, but I'm going to put a little dot where I originally began, and I'm going to put a little dot at the very end, the very tip of the last arrow. And then I simply want to connect those 2 points up. I go. And I'm going to use a dotted line again. And I want to put an arrowhead on this because my vector, or I should say my resultant, is also a vector. And I'm going to measure the length of that, and I'm also going to measure the angle it makes with the horizontal. That's my resultant angle. So if I measure this out, all right, so it ends up, it should be about 7.8. Yep. So it should come out to be about 7.8 centimeters. And then the angle, I can measure it right here, should be about 26 degrees. And I'll just put a little box around that, and a little box around this. So this is my answer, my resultant. It has a magnitude of 7.8 centimeters, and it's got an angle of 26 degrees relative to the horizontal. And that's it for another session of vector addition.